Okay, we're here looking at solving equations in two variables and specifically looking at simultaneous equations. So when we talk about simultaneous equations, we're referring to two equations that we solve together, hence the name simultaneous. The reason we solve them together is that they contain more than one variable. Up to this point, we have solved equations with only one variable. So an example here, we had a linear equation 2x equals 4. We were able to solve that by dividing both sides by 2 and getting a solution of x equals 2. Now we'll give you an example here of simultaneous equations. X minus y equals minus 2 and x plus y equals 8. So as you can see, we have two variables, two unknowns, x and y. Okay, we have two algebraic methods. There is another method that we'll discuss at another time. We have two algebraic methods. That's methods using algebra that we can choose from. So we can choose to do substitution method or the elimination method. We are going to do both. We're going to solve the same problem using both methods, and we'll talk at another time about when to use each method and why. So we start off x minus y equals minus 2, x plus 9y equals 8. So the substitution methods first we're going to do. The idea basically here is that you would rearrange one of the lines. Okay, so you basically look and see, you want to isolate one of the variables on its own. So we're going to take the first line and we're going to just get x on its own. So that will be x minus y plus y equals minus 2 plus y. So we're just taking this is the first and this is the second one. So we're taking the first one and we're just going to get x on its own. Okay, and why do you think that would be useful? Well, what that allows us to do now is to take minus 2 plus y, which is what x is equal to. We've just worked that out. Minus 2 plus y, and we're going to substitute that. So we've rearranged the equation 1, and we're going to substitute minus 2 plus y in for x in line 2. Okay, so we're going to write out equation 2 exactly as we got it at the start of the question. X plus 9y equals 8. Now we're going to take the minus 2 plus y and we're going to sub it in. We're going to sub it in right here instead of x. All right, so minus 2 plus y. Now we'll just put it in brackets because it's a good habit to get into. Anytime you substitute in, put it in brackets. All right, so we end up at minus 2 plus, we can remove the brackets then because there's nothing that is going to affect them. So then we're looking at like terms here. So we end up with minus 2 plus 10y equals 8. And once we have a single equation, which we have now, we're reverting back to how we solved linear equations in one variable, because we only have one variable now. So in those situations, if you can recall, we basically tried to get all the terms that had the variable, in this case y, on one side, and anything that didn't, that had numbers by themselves, constants, on the other side. So to do that, we need to eliminate the minus 2 from the left hand side. So that means to do that, we do the inverse operation. If you can recall a previous video, inverse operation, minus 2 plus 2 is 0. So we'll end up with 10y equals 10. Okay, so we have 10y equals 10. So again, we want to solve this, we need to get y on its own. So to do that, again, we do the inverse operation. 10 and y are attached by multiplication. So you do the inverse operation, which is division, and we get a final answer of y equals 1. Now, again, we've paused for thought here. Have we solved this? Have we solved this simultaneous equation? Well, no, because remember, we started off with two variables. So if we go back up to the very start, we were asked to solve this. So you need to know what x and y is. At the minute, we just have y. So the method we use then is we basically look back at the original ones. X minus y equals minus 2. So we'll write out that one, the very first one, x minus y equals minus 2. Okay, you see that back up there? So we're taking that one. And again, similar to what we've done previously when we've figured out something, we take the 1 and we substitute it in there for y, because we now know what y is. It's no longer an unknown variable. We now know it's a known constant or a number. So we put the 1 in there, and again you can use brackets just to make sure. So again, x minus 1 equals minus 2. So x minus 1 equals minus 2. Again, we know that we have to get x on its own, so we have to add 1 to both sides. So we end up with x equals minus 1. So our final answer is x equals minus 1 and y equals 1. So x equals minus 1, y equals 1. And again, it's you would normally put them as an ordered pair, a coordinate minus 1, 1, because we'll discuss another time. Actually, what you found is a point of intersection of two lines. So we'll go back up here. We've done that. That's the substitution method done. Elimination method. Elimination method is where you, from its name, you eliminate one of the unknown variables. Okay, so you eliminate, so your first objective is to eliminate either the x's, in this case, or the y's. Doesn't matter which, you'll get the exact same answer down the end. But it makes sense here because we can choose to do the x's in this case here. So to eliminate them, you treat it as if it's a sum. Okay, so if I was to add the x's as they are together now, I would end up with 2x. Okay, for me to try and eliminate them, I would have to have an x, a plus x, and a minus x, because if we add them together, we'd end up with 0x, and that would eliminate the x's. Okay, so how do I change one of them into a minus? What we do is, and again, remember our rule about doing the same thing all across the board, what we do is we take equation number 2, for example, and we're going to multiply everything by minus 1. Multiply everything by minus 1. So again, equation number 1 stays exactly as it is. Equation number 2 turns into minus x, because x by minus 1. 9y by minus 1 is minus 9y, sorry. And then we have 8 times minus 1 is minus 8. All right. Now if we make that into a sum and we add them together, so x minus x, you have eliminated the x's. Minus y minus 9, minus y minus 9y, minus 10y. Minus 2 minus 8 is minus 10. Okay, and this is hopefully looking a bit familiar to the previous one. So we want to isolate y, get y on its own. So we want to divide both sides by minus 10. It's a coincidence that on both sides there's minus 10. So we end up with y equals 1, which is reassuring because that's what we found out y to be on the last method. And again, same as the substitution method, you take your equation 1 or 2, it doesn't make a difference, and you sub in 1 in for y, and you end up with x minus 1 equals minus 2. So you're adding, remember we said we're going to add 1 to both sides to eliminate that, and we get x equals minus 1. So our final answer is x equals minus 1, y equals 1, or as an ordered pair, minus 1, 1. So you have the substitution method, which we did first, and we have the elimination method, which we did second. Both end up getting the same answer. Both are perfectly valid. And again, we'll talk at a later date as to when you use which one and why. Okay.